Hello, this is Charlene. In this video, we're going to be talking about the normal distribution, specifically with respect to z-scores. The z-score is a value that describes how many standard deviations a data item X in a normal distribution lies above or below the mean. And of course, here are all the pieces and parts. The X stands for the data item or the number that they want you to pay attention to. The X bar means the mean of that data group. S stands for the standard deviation, and Z stands for the z-score. Specifically, we have this formula. The Z is equal to the data point minus the mean divided by S. And again, here is it is explained in real words. The data item they want you to pay attention to minus the average of the group of data, the mean, divided by the standard deviation, and that will give you the z-score. They also tell us here that the data items that are above the mean will be positive, below the mean will be negative, and the z-score for the mean, which is in the middle, will be 0 because it is neither positive nor negative. Okay, let's look at what we're talking about when we say normal distribution. So this is a standard normal distribution curve. Sometimes people call it a bell curve because it looks like a bell. So we need to understand that when it is right in the middle, the z-score right in the middle is 0 because that is where the mean or the average is. It's where the mean or the average is. And these numbers here are negative because these numbers would be below the average. These would be below the average. And these numbers on this side are positive. And these are z-scores. That's a -1 z-score, -2 z-score, -3 z-score, +1 z-score, +2 z-score, and +3 z-score. And all these numbers that are positive are considered above average, above the average. Okay, so what kinds of things can be represented by these kinds of graphs? Well, we can have grades as a good example because you will have, when you have grades, you'll have an average grade like on a test, and then you'll have some of your students will make above that average, and you'll have some of your students will make below that average. Same thing for pets, the number of pets that people own. A lot of times there's an average number of pets that people may own. And then there will be people who have a lot more pets and are above average, above the average number of pets in their home. And then you'll have people that are below average or even maybe even have 0 pets in their home. Also, income. Income can be expressed in terms of an average income, and every state has a different average income. But then there are people who will make above average incomes, and there are people who will make below average incomes. So these are just 3 different data sets that we might think of and could be represented by a standard normal distribution. But your z-scores are definitely related to that. Your z-scores have to do with how far above the average are they. And that first line, the number 1, means that it is 1 standard deviation above the average. That's what this number 1 means. Number 1 means that it is exactly 1 standard deviation above the average. And if you have a z-score of 2, that means that it is going to be 2 standard deviations above the average. And the same thing goes for the negative numbers. The negative numbers, this right here would indicate a score that lined up with that would indicate that it is 1 standard deviation below average. And this one right here would indicate that it is 2 standard deviations below the average. Now, can you have z-scores that are actually in the middle somewhere? Sure. Right there, we could have a -1.5, -1.5, and that would indicate a score that fell at this location on the graph. So you would have a score there, but it would have its unique z-score. So if your score falls between those, it can have a z-score that is between there. Let's say that we had one that was right here. Well, the z-score there might be like 1.75. And if a person's score fell right there in the data list, then it would have an above average z-score. And it means that score would be above average for that test. Okay, hopefully that helps you kind of understand what the connection is between a z-score and a normal distribution. Okay, our first problem says a set of data items is normally distributed. It has a mean of 60 and a standard deviation of 8. They want us to convert each data item to a z-score. So the data item that they want us to pay attention to is 78. We don't know what that's about. It could be a score for a test. It could be a speed. We don't know. But for the purposes of finding the z-score, we do not have to know what data set that score is coming from or that number is coming from. So we are going to do the z-score is equal to the data point. Well, the data point is the 78. So that's equal to 78. And then we're going to do minus the mean. Well, they tell us that the mean is 60. So minus 60. And then we're going to divide that by the standard deviation. And they tell us that the standard deviation is 8. So that means that the z-score is going to become 18 over 8 because we're going to subtract 78 minus 60. And then if we go get our handy dandy calculator, we can do 18 divided by 8, and that's going to give us 2.25. So that means that the z-score for this score of 78, this data point of 78, is going to be 2.25. So what does that mean? The 2.25 means that 78 is 2.25 standard deviations above the mean. Okay, our next problem says that our data set has a mean of 60. It has a standard deviation of 8. And the data point they want us to pay attention to is the 60. So that means we're going to find the z-score of a 60. And it's going to be equal to the data point they want us to pay attention to, which is the 60. So it's going to be 60 and then minus the mean. Well, the mean is 60, so it's going to be minus 60, and then divided by the standard deviation, which is 8. So divide by 8. And of course, that is going to be 0/8, which 0/8 is just equal to 0. So what's interesting about this is that if we have a z-score of 0, that means that our data point of 60 is the same as the mean. So if right here in the middle, if there's your mean in the middle, it's going to be a score of 60. And the z-score for that 60 will be 0 because it is not above the mean, it is not below the mean, it is exactly equal to the mean. So my z-score for my 60 data point is 0. Okay, our next problem says that our data set has a mean of 60, a standard deviation of 8, and our data point they want us to pay attention to is 30. So my z-score for 30 is going to be equal to the data point of 30 minus the mean, and the mean is 60, divided by the standard deviation, which is 8. And then we're going to work that out. So 30 minus 60 is a negative 30 in the numerator divided by 8. And when I work that out with my calculator, negative 30 divided by 8 is going to be negative 3.75. And what does that mean? That means that the z-score for 30 means that 30 is 3.75 standard deviations below the mean. It's a negative z-score, so it means it's going to be below average. Okay, this next problem says the mean weight of newborn infants is 7 pounds and the standard deviation is 0.8 pounds. The weights of newborn infants are normally distributed. Find the z-score for the weight of 9 pounds. So they want us to figure out if 9 pounds is average, if it's below average, or if it's above average, and the z-score will be able to tell us that. So we're going to find the z-score of 9 pounds, and that's going to be equal to the data point they want us to pay attention to, which is the 9 pounds. So 9 minus the mean, and they tell us that the mean weight is 7 pounds. So minus 7 divided by the standard deviation, which is 0.8. So 0.8. And that is going to be 9 minus 7 is 2 divided by 0.8. If I put that in my calculator, 2 divided by 0.8 gives me 2.5. So 2.5. So let's think about what that means. That means that the z-score for 9 pounds is 2.5. It is a positive number, and this means it's 2.5 standard deviations above average. And does that make sense that a 9-pound baby is above average, especially if the average is 9 or 7 pounds? So that makes sense, right? That a 9-pound baby is above average. Okay, the next problem is still talking about the newborn babies. It says that the mean weight is still 7 pounds, the standard deviation is still zero point 0.8, and they want us to figure out the z-score for a 7-pound baby. So we're going to do the z-score for a 7-pound baby, and that's going to be equal to the data point minus the mean. So it's 7 minus the mean of 7, so 7, and the standard deviation goes in the denominator, so 0.8, and 7 minus 7 is 0. 0 of anything is still just 0. So that means that our 7-pound baby has a z-score equal to 0. And that means that our 7-pound baby is exactly equal to the average. Okay, the next one says again that the mean weight of the babies is 7 pounds, standard deviation still zero point 0.8, and they want us to find the z-score for a 6-pound baby. So that means the z-score of a 6-pound baby is going to be equal to the data point of 6 pounds minus the mean of 7 divided by the standard deviation of 0.8. And 6 minus 7 is -1 divided by zero point 0.8. And I can look at my handy dandy calculator and do -1 divided by zero point 0.8. And that gives me a standard deviation of -1.25. So equals -1.25. So that means that our 6-pound baby has a z-score of -1.25, and that means that this 6-pound baby is 1.25 standard deviations below the mean because it is a negative z-score. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.